I'm Ben Johnson. This project is for the final for Geography of Global Health, and mine is Landscapes of Health, addressing the health concerns in the Twin Cities. Just a quick outline of what I'm going to show you is I'll start off with some background, and then I'll get to the research question. Then I'll go through our three models, the heat island, cost distance to emergency services, and the vulnerability. Then I'll combine all those into a final map and reach some conclusions from there. My purpose of this project is just to understand and show visually the differences in Twin Cities landscape when it comes to heat, cost distance to emergency services, and vulnerability. I kind of want to compare these to different health issues and kind of show them, visually on how we can understand the different health effects in each of these different parts of the Twin Cities. Let's start off with a little background here. First quote is from ScienceDirect.com. Temperatures in urban centers are also chronically higher than in adjacent outlying areas due to the urban heat island. This is basically saying that the temperatures in urban centers, so that's places with high population density, there's a lot of people that live there, there's a lot of buildings, are going to be higher than those outside areas that are going to be more rural and more farms there and ranches and areas like that. And that kind of goes with the second quote. Level of exposure to heat stress was highly correlated with place-specific measurements of ecological variables, vegetation density, and open space. And I'll look more at that, and I'll show some maps pertaining to biomass and its effect on the urban heat island. My research question is, using 2010 census and ACS block group data obtained for the Twin Cities Metro, what areas are most affected by heat, vulnerability, and cost distance to emergency services? Also, what can we learn about specific health concerns in their relation to where people live? Basically, what I want to see here is, using these three things, the heat island, vulnerability, and cost distance to emergency services, is I want to put together a final map showing this isolated hot and poor, where there's poor people living in places that are hot, and we want to see how these health concerns in the area, specifically heat stroke, and how these maps can kind of show where those are. Okay, this is our study area. That is the Twin Cities metro area, just Minneapolis, St. Paul, and the surrounding suburbs. There's a lot of lakes, a lot of highways, a lot going on here, and I think it's easy to see through all our maps, what we're trying to look at and what we're trying to accomplish. Our first model is for the urban heat island. An urban heat island is basically an urban area that is warmer than its surrounding rural areas. We'll show you that in the model and just kind of how it affects the whole general landscape and just show this final visual representation of the urban heat island. And we kind of want to see its effects on heat stroke. That's for Ramsey County. And we kind of want to understand the consequences of growing cities and their effect on the environment as a whole. So maybe in the future we can see more variables other than these and just kind of show this whole urban heat island on a grander scale. Okay, this is our urban heat island model. We start with lakes, which is a shapefile, and we put that through the feature to raster tool, which basically makes it a way for GIS to understand lakes in terms of putting it as part of the equation, so then we can add it together into the final part that turns out to be the urban heat island. After we've made it a raster, we can reclassify it so it can line up with the impervious and biomass, and I'll get to these variables and so it can be more understood by you. And we finally put these through the raster calculator, which adds them all together and gives us our final map for the urban heat island. The first one is the impervious layer, and this basically just shows pavement in the Twin Cities. That's all it is on here. All of the black is where the pavement is, so more black, more pavement. And we can see close to downtown over here, that's downtown Minneapolis and downtown St. Paul. We will see a lot of pavement, and we know that this is associated with higher heat and contributes to the heat island effect. This is our biomass layer. It's essentially the opposite of the pavement layer. Pretty much shows where trees and vegetation are, and we know that these contribute well to the urban heat island in a negative way, meaning that they do not contribute to the heat island. They should clean the air and make it cooler for everyone around. And once we add these together, added the lakes in there as well, we have the impervious layer and the biomass layer and the lakes layer all added together to show this urban heat island. And we can see here that since the impervious was added twice, that's the two arrows on the model, the heat island is much greater in these downtown areas of downtown Minneapolis, downtown St. Paul. It shows the overall effect of that pavement on the urban heat island. And basically where it's all going to be the beige color or even into blue is where there's more biomass and that heat island is less. Second model here is access to emergency services. Emergency services are fire departments and hospitals. But what we want to do with this model is show how easy it is for someone to have access to these services. We've shown that, and there's studies that show that the increased distance from hospital is correlated with increased chance of death. We want to see where these people are isolated, basically, just to show, along with our other models, to see how vulnerable they are in terms of poverty and their accessibility in the Twin Cities area. Okay, this is our cost distance model. Over here on the left we have fire departments and hospitals. Use the merge tool to put those together into one map, and I have the map for that, and I'll show here in a second. We also have the friction of distance model. I also have a model for that I can show you, and it goes through the cost distance tool to get us the final cost distance to emergency services. This is our first map here, and it's just emergency services. All it shows is hospitals and fire departments and where they are in the Twin Cities metro area. And you can see here they're very evenly spaced out and they're well planned out, and that is a good thing to see. This is our friction of distance map here. And basically what it's showing is how easy it is to get from one place to another. Essentially, as I've had it described to me, is if the map was laid horizontally and if you were to pour water over it, how easy the water would disperse is basically how easy it is, or how hard it is would be how much friction there is for the water to move. So here on this map, everything in blue, those are the highways, where it's very easy mobility for everyone there. On red, we got lakes and the airport and the river, and it basically shows how easy it is to move across the map, and how this will play into our cost distance to emergency services is how easy it is to get to these emergency services for people depending on where they live. Here's the final map, and it basically just puts the friction of distance together with the hospitals and fire departments, and it kind of shows this cost distance, which is how easy it is to move from cell to cell on this map. It's kind of GIS jargon of how easy it is to move in reality. So where you see the yellow here, or the orange, that's where it's much easier, or the access to these emergency services is much easier than it is out in the country. You can kind of see outside of the area where it's purple or pink, where it's much harder to get to these services by car, essentially. I guess this doesn't take into account helicopters or other transportation modes like that. Third and final part of this project is vulnerability. What we want to see here is just a bunch of variables we can get from the census data, and the ones I'm using here: percent English speaking, percent rent burden, percent no high school, median age, percent white, percent over 65, and percent homeowners. When we put these together, we can kind of see how standard of living is affected from all these. I mean, we kind of want to see who's poor in the Twin Cities area, and show how that affects our kind of overall arching theme of health, and specifically in this one for heat stroke for the Ramsey County administration. And then we can put these all together in the end to show this isolated hot and poor, and this is kind of the poor part of it. And this is our model here. I mean, it's a lot to look at real quick, but over here on the left we have our block group data, and we put those into rasters just kind of for something that GIS can now read, and we've put each one of these variables to reclassify, so now they're all standardized. And once they're all standardized, instead of combining them in the end, be like comparing apples to oranges to bananas. Now once we've standardized them all, they're all apples, apples, apples all together, and finally into this raster calculator, which adds them all together into one map, and that's going to be our vulnerability map. This is our final vulnerability model. It kind of shows, together with all these variables from the census data, who's poor and who's not. That's kind of our definition of vulnerability in class. We want to kind of see more from a poverty point of view. Some people might have different views of vulnerability or different definitions of it, but this is kind of what we're going with. And in here in this map, you can kind of see the purple is where the people are more vulnerable, and the green would be less vulnerable. And they're surprisingly kind of mixed in. We got people mixed in, poverty and non-poverty. And with here where there is no purple or green, all the gray space, that's where people don't live. So we put that on there just because those places would show up and kind of skew the the visualization of what we're trying to see here. This is our final model. On the left here we have the three variables we were using: the vulnerability, urban heat island, and cost distance to emergency services. We've reclassified all of them, just kind of put them together again, that apples to apples to apples again, and we put them through a raster calculator which combines all three and puts all of the layers kind of together into this final map. So this is our final model, basically showing who's isolated and who's poor. The reddish, orangish colors are more isolated and more poor. Those are the people that we determined were more vulnerable, fitting to our definition of vulnerability, kind of more of a poverty sense as well. And then the isolated is also more red, orange. That's for the people that were kind of stuck in that urban heat island and also didn't have very good access to those emergency services. Then the green is just vice versa. Who isn't isolated, who isn't poor relatively, and it kind of shows the landscape of the Twin Cities and just kind of where everyone fits on this map. Again, like our vulnerability map, we're not showing, we have the uninhabited layer also in there, kind of showing where people aren't, and it kind of helps not have a skewed image of what we were trying to see. So we come to a few conclusions from these models. Those living in areas nearest to highways have greater access to the emergency services. So the people that live next to these highways, there's cars and ambulances traveling on them. There's no stoplights or things like that, so it's very easy to get to places, quickly if that's, if it's an emergency. But again, since there's a lot of pavement in those areas, and they're also more susceptible to this urban heat island effect, where the temperatures are hotter, where there's more concrete and more pavement. This might contribute to this heat stroke variable we're trying to look at, where even if you live close to these emergency services and you can be treated for this heat stroke, you also live in the place where the heat island is. And then again, with those vulnerable variables, we get a good sense of poverty, and we can kind of look into how poverty is related to this heat stroke effect. Possible future research that I came up with was to maybe compare these results to other cities in the US or internationally. Just kind of see the different relations between the two, and what can we learn from each city, and see the similarities and differences. Another thing to look at is probably just to put this next to a map of heat stroke and see, are we actually seeing where these people affected from heat stroke are? Are we able to put that in an image based on vulnerability, the access to the emergency services, and the heat island, and just see how each one of those has an effect on this heat stroke variable we're trying to look at. So here's our data that we used for the urban heat island, and for the isolation model, this was the cost distance to emergency services, and this is our data for the vulnerability model. So just some final thoughts about the project in general was basically that we were able to see from three different models health effects, and how the area that we live in and where we're from is affected by those things. We're able to see who's isolated, who's poor, these different places, and that we don't really think of, and it's basically to give awareness to what's around us.